రామకృష్ణ గారు
సార్ షల్ వి
ఓకే సార్ ఓకే రైట్ అంటే మీరు అవునా కాదా అని కోహోస్ట్ చేసాము చేసుకోండి just a few minutes sir
no
faculty
problem sir
will introduce you then you may
okay
start
sir
right, sir.
సార్ స్టార్ట్ చేద్దాం సార్. కెమెరా సార్ స్టార్ట్ చేయమంటారా సార్? కెమెరా సార్ కెమెరా సార్
చెప్పండి రాజశేఖర్ గారు.
స్టార్ట్ చేద్దాం సార్.
స్టార్ట్ చేద్దాం అంటే రెడీగా ఉంటే స్టార్ట్ చేయండి.
ఓకే సార్.
స్పీకర్ కూడా వచ్చేసారు.
ఓకే సార్. ప్రియదర్శిని మేడం అన్మ్యూట్ చేసుకోండి మేడం.
సార్
ఎస్ మేడం.
ఓకే సార్.
వీడియో ఎస్ మేడం.
ఓకేనా సార్?
స్టార్ట్ మేడం.
Good afternoon to one and all. Myself, Priyadarshini, Assistant Professor of ECE Department, Kudlavalleri Engineering College. It's my immense pleasure to introduce the speaker of today's session, Engineer K. Ramakrishna Garu. Engineer K. Ramakrishna Garu obtained his master's degree from Andhra University. He has more than 14 years of experience in embedded system development and networking domain. Currently, he is working as Senior Design Engineer in Xilinx. Prior to that, he worked as Senior Engineer in Cisco Systems. His areas of expertise includes embedded Linux, kernel programming, device drivers. He also pursuing PhD in IIIT Hyderabad. With these few introductory words, I would like to invite Engineer K. Ramakrishna Garu to the session. Sir, please join with us.
Hello, good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Please.
Yeah, I will start the session on this. I'm sharing the screen. Please let me know.
Okay, sir. Okay, sir.
Sir, Ramakrishna Garu.
Yes, sir.
Initially, you may speak with the video.
Okay.
Then you may start.
Yeah, we can see. Yeah. Okay, sir. I can stop my video, right?
Initially, you may start with video. Later on,
Okay,
if you're
sir.
interested, you may continue
Yeah.
with video. Otherwise, you may off your video. Depends on.
Okay, sir. Can you view the screen?
Yes,
the
sir.
IoT
Yes, sir.
caching.
Yes, sir. Yes,
Is
sir.
that same slide is appearing?
Yes, sir.
Okay. Okay. In this session, I would like to talk about IoT caching.
But it is not in slideshow, I hope.
Yes, sir. I will put in the slideshow mode.
Yeah. Yeah.
So what I would like to cover is IoT introduction, very minimal. Already these things are covered in earlier sessions. And what are the IoT challenges we are going to face right now? And IoT caching, how the caching will help to address the few of these challenges. And one of the caching, by using caching, we can save the energy. Um, that is for that there is a one research paper recently published on the scalable and energy efficient concurrent binary search tree. I will introduce that concept, and I will show you one demo on simple IoT. It's not like a very protocol like MQ22 like TT like that. Just simple demo I have planned with REST API concept with a few of the sensors. So I will show that demo. So this is the agenda in this talk. I will switch or turn off my video so that I can have bandwidth problem. Yeah, the IoT has been deployed as a new paradigm. We can connect to a couple of devices, applications, and all with and without human intervention. These are few IoT applications like in our day life, a home automation system, in enterprise clouds, utilities, energy management, metering, smart metering, medical healthcare, transportation, and as well as large scale deployment comes to the uh, smart cities kind of thing. So in the IoT is basically enabled from the small scale network to the large scale network. In the small scale network, like a simple sensors and with REST APIs, we can able to do and send it to the GUI. That is a one kind of simple things. And again, the protocol based MQTT kind of thing, and like smart cities and larger applications. So this is a developing and widely established things at this moment. What are the challenges the IoT currently has is the data. So if you take the like weather forecasting system or some of the data like you can assume like wild animal protections things, there we have placed the cameras to like surveillance purpose and count the tigers reservoir system, and in all these states you will get the huge number of data. So the processing of the data and storage system, the communication network, so that these sensors and all deployed at one place, the data has to be collected and it will be stored in the some centralized server, and this data has to be again uh, processed, and it has to give it to the end user. It's a general architecture is like some 3-4 years model, like the cloud based system. So whatever the sensor data you will be have, those data will be uploaded into the cloud. The end user by using web browser interface, he can able to uh, view the data, whatever the respective thing. So here the IoT data is be used, and here the data consumption as well as the transportation, the bandwidth, energy, time, these are all the constraints here. So while you are processing the huge amount of the data, these are all the considerable factors. And another one is the sensor data. Generally the sensor deployed in various places like icebergs and all. So here few sensors works with the battery power supply, and here the
Excuse me, sir.
crucial. Yes sir.
Sir, slideshow unda, sir. Is there?
Yeah, yeah, can.
Means we are in the first slide only.
Oh, so okay, IoT challenges, the second slide I'm taking towards to the IoT challenges.
We are having only first slide, sir. IoT catching.
Oh, okay. Let me stop screen share and I can share. Maybe I can. Can you see this slide number 4?
Yes,
Not
sir.
just
Slide
I'm
number 3
sharing like
is there, sir.
it's not slideshow. IoT
Yes, sir, it is
challenges.
not.
Okay.
Yes, sir. It is not
Okay.
slideshow,
It's
sir.
taking a refresh. Yeah. I'm not putting slideshow. Maybe I'm getting so network bandwidth.
Okay,
So,
sir. Okay, sir.
yeah. So these are the few challenges. These are the challenges in IoT, like energy, bandwidth, power. So a couple of solutions has been proposed to these things. One of the solution is the caching. So from the caching is a one of the way. Like there are a couple of research papers has been published on this one. I have seen like multiple things. One of the caching approach, I want to present two caching solutions here. Uh, Whatever be the research papers, I have gone through that. Um, this is one of the IEEE paper. This is based on the edge computing, and this is another paper on the energy harvesting one. I will
Sir,
introduce the basic
sir,
things. So,
papers
yeah.
కనిపెట్టలేదు, sir.
Okay.
And when you are making the slide share, only that one will be visible, sir, whichever you are sharing.
Okay. Okay. I think, yeah, sorry.
You must stop this slide show, sir. Then you must share the other one, sir, which you want to show.
Okay. Yeah. Got it. I have not, this is a screen share might be.
Yes, sir. First, you must stop that screen
Yeah,
sharing, sir.
yeah, I got it. Yeah. Okay. Sir. Yeah, this is just I want to show you these what are the papers I referred here. Hope you can see this paper.
Yes, sir.
Yeah, so this is one paper on the IoT sensing for the energy harvesting. This is the one based on the caching one, and the second paper. This is a caching transient with a deep info reinforcement learning. This is a base ML based other approach. Okay. So I will give the brief introduction on what how the mechanism as the proposal has been done in these papers. Here the caching allows a fixed facility. The wireless accessing point here acts as a gateway for the sensors. it stores the data. And here the caching data temporarily it will store instead of activating the sensor for every sensing time. So whenever any request comes from the user, instead of every time it accessing the sensor, instead of that it will maintain the one caching cache. It will maintain the cache. From the cache it will be uh, give the user based on the cache changes. So here the sensor will sense the torque, like an example like noise level or anything from environment. It will be captured and it will maintain in the cache. So this cache is at the access point. It has a fixed power supply, so user can send the request and any query to send to this gateway. So whatever the cache data it will be provided. Again here one of the cases like how frequently update the data. So here that is a concept called data freshness. This data freshness is one of the crucial factor while you are maintaining the cache. So whenever you are requesting the data, user requests the data, it will fetch from the sensor and it will maintain. So instead of every time you are getting the data from the sensor, you are giving the data from the cache. So how here again the cache updation also required. Generally this we call as a cache coherency, right? In our standard desktop machines also we have the cache coherency. Without any inconsistency data you have to maintain. So there is a couple of protocol for to maintain the cache coherency, right through right back kind of thing. So here in this scenario how it will be happen. So there are a couple of proposals has been implemented here to maintain the data freshness here. uh, so one of the approach here in this paper they are suggesting is so they maintain the one timer here. So based on the timer the periodical updates will be happen. Like suppose the data is particular amount in the bit is in specific amount of time. If the data is retrieved, then it will get from the cache. If that is not the case, then it will take the data from the sensor again. It will update the cache and it will give. So this is the model. This is system model has given in this paper. This is one of the approach here based on the timer functionality. So the second approach is the edge computing. So edge computing, here you can see in this model, the edge computing, like edge maintain the cache. What is the edge and core? In the networking terminology, you might hear like a edge node and a core node. Usually core node is like your server. Edge node is your end device before, like computing device. The edge node, the multiple devices are connected to your edge node. Here you have the data producer and data consumer. So data producer is a sensor. So from this one the edge node maintain the data, and the data consumers will take the data from the edge node. So here the cache is maintained at the edge node. So the producer, the sensors and all, whatever be the sensors or any other various different ways, it will produce the data. These are all things stored at the edge node. This data will be consumed by the data consumer, and the these are request stored data and return the data. In this context, in this context the data production and consumption, again the data freshness, how frequently access the data based on this life cycle. Like they calculate like the age. Suppose the sensor data validity is some 20 milliseconds life period. If the life period is greater than the span, like whatever the data arrival, then it will be, it's a fresh data. Like the what the request is came before the data expire, it is a fresh data. That data can be consumed from the edge cache. Otherwise it has to again get request from the producer, it will take. It's a similar to whatever earlier, but in that context it maintained based a timer. Here based on the data freshness, the how frequent data freshness they used yeah, in the ML side they used one of the algorithm. So these are the two techniques, one which I have gone through that for caching thing. And apart from that, recently we found these are the others. So recently, with a few of the people, we worked on the another data structure oriented is uh, cache based one, fat node concept. Just I will go through that concept. That is the one which we worked on that. Whatever the thing which I'm going to present now, this can be used in IoT. Not only in IoT, it can be used in the standard any other like desktop machines. Everywhere we can use this solution. So basically, the caching mechanism, how we can save the power by using the caching different methodology. In this case, we are proposing like one of the thing like scannable and energy efficient concurrent binary search tree with fat nodes. So uh, whenever the information retrieved from the sensors, the information will maintain in various formats, right? The come to the data structure oriented, linked list or trees oriented. So while you are storing the information in the trees, obviously when you are accessing anything, it will come to the cache. From there, the CPU will be accessed. Suppose if you are the information is in the maintained in the tree format, if you maintain the tree, generally the tree access time we represented as the height of the tree. Based on the height of the tree, you can represent the binary search tree. The binary search tree property is the root node and left hand child. So the left child is the left child is less than the root, and right child is greater than the root. So here the solution which we are proposing is we maintain the binary search tree in such a way the height of the binary search tree will be lesser, so that the access time will be lesser. So whenever the how it is related to energy save, energy efficient, like based on the data transaction. Like if you are minimizing the data movement, then obviously you are saving the energy. You can able to save the energy and as well as a cache miss ratio also. So if you are maintaining the structure in the fat node concept, the cache misses are lesser compared to the regular binary search tree. So usually the regular binary search tree will be in this way, like one node you will represent like data value, left subtree and right subtree. So whereas comes to our this fat CBST node is the fat CBST node will contains the one key value along with the arrays. So let's assume if you want to store some data values like 1003 and 4000. So here the value is based on the key into factor. Like this is a formula, key into k and plus index. The and here the k is the fat node size and index. Let's assume if you want to store any data elements 1003, right? So here what we do is the key value divided by 4. Suppose 1003, because key size fat node size is 4, so 1000 by 3, that is 250, right? So in the 250 node, and the index is a 1000 and 3 is the index. So here 1000, 1000, 1003. So here we will insert this data element here. It will come to here. So let's say if you want to insert the 4000 by 4, that is a 1000 in the divided by 4, it's a 1000. The 1000 node will be 1000 node will be created and insert here the 4000. This is the key value. Yeah, this is the one. So here the 4000, the 4000 here the index will be referred here. So here the insertion will be happened. And nowadays all the processors are going with the multi-core architecture. So when the processor going to the multi-core architecture, usually we have the problem with the data consistency, right? Suppose if you take the multi-core architecture one, there are various cores will be there. Each core has it's a one cache. That is how we can cache as a L3 cache or L2 cache. And each core has a one common cache is a L1 cache. That is representing to your main memory that is connected to the CPU. So when you are suppose while you are accessing one core is accessing data on one cache, obviously it will be invalidate the data. It will has to acquire the lock. So that will happen in the multi-core architecture. Suppose you are accessing some common shared data, then you need to maintain the locking mechanism. So here we will maintain the read lock and write locks in order to make the consistency. Similarly, while you are deleting the node, what we'll do is the 4000 by 4, the 500 is a key value, and this is a 0th index, and this element will be deleted here. 4000 by 4000. Sorry. So 1 second, I will. Yeah, these are the authors of this research paper. Uh, we contributed from the implementation side. Yeah, this is just inserting the node which I demonstrated. So 1003, right? 1003 here the fat node size is a 4, and by 4 it's a 250, and 3 is the index. This is a insertion. Suppose if you want to insert the 4000, then 4000 by 1000,
Sir,
and this is a yes sir.
sir, paper visible లేదు sir.
Oh, okay. Can you see my this fat operation, sir?
Yes,
The
the
fat
PPT is
CBST
available, sir.
tree.
Fat kept it after removing 4000, 2000 and 2002.
Oh,
That
it is
there,
okay.
Miss, first you must remove the sharing, sir. Stop
Yeah.
the screen sharing and then.
Okay, yeah. Okay, remove the sharing and. I'm operating from Ubuntu because of that.
Okay, sir. Okay,
yeah,
sir. Okay,
because
sir.
of that a little bit. Usually all these presentations and all.
Yes, sir. Yes, sir.
Somehow I'm not able to do both the things in parallel. It's the slide view. It's not coming up. Okay, sorry about
Okay, sir.
that. I will show the. That might be the reason people still using Windows. somehow it is not coming. Uh, okay, so just I want to show this. If you want to delete the 4000 node, right, by 4, you will delete the index of the 0th location. And if you want to delete the 2000 by 4, it's come as 500. So if you want to delete this 500 root node, it is again applies like our binary search tree. Usually in any of the node, if it is as a left child and right child, what we'll maintain is we'll take the smaller minimum element or maximum element, and again we will adjust that root tree node so that it won't lose the binary search tree property. So you have to follow the same here. So after the deleting of the this node 501, then the one more thing is a skewing will come up. What is the meaning of skewing is, suppose if you are deleting so many things like insertion or deletion happen at one level, sometimes your binary search tree height will increases. That means you will have left side only one node, but right side you might have some 10-15 nodes. That is called skewing. As I mentioned, if the that height of the tree is increases, obviously the search time will be increases. Then we have to do the skewing. So that means you will do the left rotation or right rotation, so that again the height of the binary search tree will be balanced. So the same skewing will apply for this data structure also. So if you want the programming side, as I mentioned, this concurrent binary search tree, basically the concurrency. So in order to protect the data from the different multi-cores, we have to use the locking, either read lock or write lock mechanism. So the read lock and write lock we will maintain in the locking system. This one is implemented in the Java. The Java has a very easy way of the reading and write locking mechanisms. Yeah, just we have tried with multiple threads. We have done created multiple threads, reading and writing and deletion operation. So all these threads will execute in parallel. And while you are performing any insertion, here the advantage is suppose if you want let's assume in this tree binary node, let's assume if you want to insert any of the suppose let's say one core one thread, let's assume each thread is running on various one thread is inserting node here, and other thread is inserting the hello, excuse the net is disconnected. Can you able to see my screen now?
Yes, sir. It is same screen, sir. Removing 4000, 2000, and 2002. Yeah. Yes, sir.
Yeah, remove. Yeah, that's true. So yeah, in this case, what I'm explaining is, suppose if you want to insert if you want to insert the node in one of the same fat node, two threads can able to do that concurrently. Let's assume one thread is inserting the node in a 0th one, and another thread is third node. So both can do the in parallel without any acquiring the write lock. So both can be done, can do independently. So by using the read lock, by issuing the read lock, we can execute these two threads parallelly. And similarly, but if you want to delete any other thread, then any node, then we have to acquire the write lock, then we'll do. So that in that way, we will achieve the concurrency. So why introducing this concept is like this one we nowadays, like the processing side, the IoT is CPUs also using the multi-core architectures. So when it comes to the multi-core architecture, we have to use the proper data structures and all. So in that aspect, I thought like it is also we can use in the IoTs. So this solution, as I mentioned, it is energy efficient. So this is it. Not only that, it is energy efficient, and the throughput also will be the best. Suppose if you take the fat node size, you can increase, then you will get the better throughput. And cache miss ratios also uh, come in the fat node sizes. If it is increasing the fat node size, you can see the better cache utilization. The cache misses rates are lesser here. And the energy efficiency also calculated on the various architecture missions. Yeah, we have seen like a better energy efficient with this concurrent binary substrate. And the time complexity and space complexity also fine here. Yeah, this is one of the proposed solution for the caching side. You can have the better cache utilization, energy efficient thing. Yeah. Uh, and the come back to the our agenda. Yeah, this is a which is a one of the prototype model which I have done for IoT related things. This is just one of the small experiment worked on the IoT side. Here I have used various sensors like temperature, humidity, altitude, pressure. These are various sensors I have connected Raspberry Pi board, and the Raspberry Pi board, as you're aware, it is coming with the Wi-Fi node. So in the same network, same IP network address mode, I connected to the host machine, and from the host machine, I can able to access all the sensor data by using the REST API. So you can see these are the various sensors which I have connected. One is a few of the I2C based sensors like accelerometer and pressure sensor, and the GPIO sensors are RGB LED. These are all GPIOs of 1 bit, like obstacle detection, IR based temperature and humidity sensor. And analog sensors are these are analog sensors. Uh, as ever, the Raspberry Pi board does not have the A2D converter, so I have used externally MCP 3008 A2D converter connected these all analog sensor and via the REST API. Mostly all these am I audible?
Yes, sir.
Hello, sir.
Yes, sir. You're
Yeah.
audible.
So earlier wherever the net is disconnected, connected back again.
Okay, okay, sir. Okay, sir.
So I have covered this slide is completed like the sensors one. Okay. Yeah, I'm repeating where I have stopped. Uh, Here, this prototype code has different these IoT sensors like I2C based sensors and a few of the GPU based sensor and analog sensors converter because Raspberry Pi board does not have the A2D converter. So this is a original board like looks like this. The Raspberry Pi board is connected to this. These are the various sensors are connected on board. Uh, this is a GUI part. Like this is we I worked on with the REST API side. So the REST API is the one which is supporting from the Raspberry Pi core board. So that from here from the web browser we will access the IP address based. So GUI things. From here we can control. This is like a same subnetwork from your mobile, whatever, from mobile or your desktop machine. You can access the Raspberry Pi board with the port number so that you can able to access this and work on this data. Yeah, unfortunately, board has some This this is the GUI from here, like suppose for the sensor, right? What is the sensor? Some details. As you know, IR is the obstacle detection, right? So just one moving as a object. Let's say in the sensor, if you place some. This is a IR based obstacle detection. The light intensity will get the data value from the sensor. Based on the sensor data value, will show the some progress bar kind of thing. This is the weather station things, temperature, pressure. You can see real time data, pressure, pressure. So I have connected I2C accelerometer and all. So when you moving the device, as per that, one object will be moved. This, yeah. So these are all the different devices connected. All the sensor data will acquire from the REST API and displayed. You can see here the from the browser port number. You can access and show the demo. Kind of like all the data you will represent it with the GUI things. So for this, the REST API, as I mentioned, like the Python is supporting with the Flags framework. Then is a Flags framework. We'll see Flags framework. We use that one the servers, the Raspberry Pi server side. So from that port number, we'll access the data. And here the JavaScript, by using the JavaScript as for the GUI purpose and uh, publishing the data on this GUI. Yeah. So this is one of the simple IoT kind of model without any protocol, only the REST API framework. So you have any queries? Sorry, so much of time disconnection happened network. This I want to publish the content. If anyone interested, I can share the code also for this framework. You can also work on uh, this prototype model board.
Participants, if you're having any queries, so please put that in the chat box, or you can raise your hand.
Okay, sir. Thank you.
Ramakrishna sir.
Yes, sir.
Sir, there was a question, sir. Have you tried implementing edge device on
Yes, sir.
FPGA?
Yeah, yeah. One thing is FPGA side, edge side also we can use one of the. Yeah, FPGA side there is a platform called data acceleration is coming up. Data acceleration, that is you can use at edge computing side also. Just I will show you one thing on this. Same question I have raised when in one of our technical session, the edge computing for data, the data acceleration one. Then I raised the same question, like we can use edge computing side. Yes, they told like it is we can able to use, but it's not like a small kind of thing. As you know, FPGA consumes more power, right? So you need let's say you want somewhere where you have the complex application, you have the more power and all, everything is there in that environment. You can use those boards, FPGAs, data acceleration one. Yeah, I will show you one. I will share some of the thing to you.
Ramakrishna sir. Ramakrishna sir. Ramakrishna sir.
Hello, can you hear me?
Yes, sir.
Sir, can you hear my side?
Yes, sir. Yes, sir.
Hello.
Yes, sir. I'm hearing, sir.
Yeah, sorry. I was on mute. Yeah. So this is a one of the acceleration card. Yeah. Yes, sir. Fine. Can you see my screen?
Yes, sir.
Is a Alveo card, Xilinx Alveo card I am
Yes,
showing.
sir. Yes, sir. Yes, sir.
Is it the same is coming?
Yes, sir. Yes, sir.
Yeah. This is Xilinx Alveo card. This is the one. Uh, so this is a data center using acceleration card. Uh, why this kind of acceleration cards into come into picture? Suppose if you want, let's say, you have the big data and all is there, right? You have big database. In that database, you want to do some search operation. Usually, the search operation and all, when you come to the standard on desktop machine, you will give it to the CPU. Based on the CPU performance, you will compute that one. That is a computing engines. So in this case, what we are doing is usually, embedded device are alternative for the next, like a power save and all purpose. The embedded device came into picture. So come to the FPGA side. Here, these cards has a built-in intelligent capability. Like if you give the some query, if you have some query like database query, some select command kind of thing, then this has a capability like the query algorithm is implemented here inside this. We call, there is other product called smart SSD. You know SSDs, right? SSD is a NVMe SSD is now coming. Earlier we have the hard disks and all in your laptops. Now all are coming with the SSD device, NVMe SSD, because these are compared. This is the Alveo board, and I'm talking about the smart SSDs. The smart SSD has capable of built-in mechanism to perform the search operation. So that is one next level of for the data center side. Here come to point to the your questions, right? So these FPGAs have the capable, the computing generally nowadays it's a common trend. Like suppose if the computing side, right? Computing is not achieve not complain now, not it is not doing by the CPUs. We are offloading. So I will show you the Xilinx Smart SSD. The edge computing no one using FPGA for edge computing. The FPGAs draw some more power. That is one thing. But performance side, you will get the better results for the DSP calculations and fast Fourier transforms and all. You can definitely use for edge computing, but power side it will be the issue. So these are all computational storage. The storage has capability of the computing. On part of this, right, uh, might be concurrency kind of thing. There is a language called OpenCL. Like if you take the multi-core architecture, the multi-core architecture, if you take the sequential programming, like you have the C programming, is it just I am asking you one question to everyone. Anyone worked on any parallel programming? Like can anyone give some parallel programming language? Parallel programming language. This is a smart SSD which has a computational storage. As I mentioned, these are all SSDs. And this is smart SSD capability is it can able to do the some of the operations like zipping. Suppose if you want to do some compression, decompression kind of operation, you no need to depend on the CPU. Thus, guys, I'm asking you the chart window. Uh, can you tell anyone of some program you can share in the community message? Any programming language, parallel programming language.
Sir, very log. Some Dr. C. Pandarishwaran sir said it is very log. Ramu sir. Ramakrishna sir.
Yeah. Did anyone respond it?
Yes, sir. Pandarishwaran sir said it is
I'm asking some parallel programming languages. Like if you want to do. Okay. Yeah. Apart from the software side, like anything like suppose yeah, that is a fine. And suppose you have the multi-cores are there, multi-core things are there. You want to write some of the uh, application. Let's assume you want to do the some matrix addition, right? It's a big matrix addition. You can want to give the addition. You give the one row in one core, and you do the summation and collectively. And okay, so one of the language I want you to introduce, that is a might be you were like OpenCL. OpenCL is a one of the parallel programming language concurrence you can do here. So here this OpenCL has a model in that sense. There is a applications will be there and kernels are there. Kernel means it's not like your Linux kernel. It don't uh, think about the Linux kernel in this OpenCL. So one kernel means one application has written things. Let's assume you want to do the some compression and all. That compression is works like you as a comes as a kernel, come as a kernel, and you write one application. From the application, let's say you want to pass some file. Okay, that file as an input application. The kernel will process that compression. So you have the various kernels are available. Usually the concurrency programming, it's a one of the challenging task that is depend on the programmer. That's depend on the programmer. if you are very good at the programming language, like so how better you are writing the program for better utilization of multiple cores, then you will get the better results. So it's one of the challenging thing, concurrency side. It's not like they will give the program language will give the constructs, but you have to use those constructs and write the your program. I will show you like how the OpenCL works, like how the syntax and how will you invoke the kernels. See, this is how OpenCL is a open computing language, one of the language widely used, okay, on a FPGAs, GPUs, in all these things also
Sir,
we can.
Ramakrishna sir,
Yes, sir.
screen కనిపించలేదు సార్,
Okay.
షేర్ చేయలేదు సార్.
So you can see this is one of the example of the OpenCL programming language. Okay, here you'll write the main program, this one, hardware device. Okay. So here these are the arguments will pass to your one. Here the variables, data variables you will send to here from this kernel arguments. So once you pass the data values, I will show you some more. This is one of the FPGA example. I will show you the matrix. Yeah, here you can see here. This is one of the example for matrix vector multiplication. So A and see, these are the two A array and X array, and it is doing the summation. So these two things, these are all independently on different cores. They can able to do these things, A and multiplication. OpenCL is a computing language. Similarly, OpenGL also is there. That is for the people use for graphics application. So this is a one of example for OpenCL. Can you see the screen, sir? Can you acknowledge one? I'm opening the OpenCL Matrix edition.
Yes, sir. Visible.
Is it the same?
Yes, sir.
Yeah. So here, as I mentioned, there are two. One is the application part, and other one is the kernel part. So you can see here in the one simple C++ plus program. This is you created two matrices in the vector format, A matrix and B matrix. Here's a finish, and you can see here the add matrix is the is the index. Index means on each core. This add matrix is it will run on multiple cores in parallel. So this is a called kernel. This kernel will be called from your application. This is a simple example for thing. So this add matrix will run in parallel, like on multiple cores, it will execute. You can specify the number of cores. So on the different cores, this will be executed. Like suppose A of 0, B of 0. A of 0 and B of 0 is executed on one core, and A of 1 and B of 1 execute on another core. Okay, so these are generally if you give it to the same thing your serial program like our standard with the C programming, it will do the sequentially. All right, so whereas this is the one with the OpenCL is a parallel programming language. As I mentioned, the Xilinx is contributing so much of things on the OpenCL. They are maintaining one GitHub for OpenCL. Usually, if you take the course as a distributed system, Yeah, these are all comes as a SD acceleration. This is a SD acceleration repository. Yeah, the OpenSL, as I mentioned, it's a pair programming language. These are the various embedded platforms which support SD acceleration. So what you can do, you can execute applications on these embedded boards. These are coming in the two variants. Few boards embedded will come direct like a standard boards. Some of the boards will in extension. From the extension you connect x86 server. You connect the FPGA board on the then here do the either emulation or you can directly execute on the hardware board. So these are the various SD acceleration platforms supported by Xilinx. And for different applications maintained here, acceleration side. Somehow my network bandwidth is less, so when I open any of these windows, the disconnection is happening. Yeah. I want to show two kind of platforms usually on any of the embedded boards. Few of embedded boards, like if you take Raspberry Pi board and all, the simple embedded boards, they draw the power from the fire, like your power supply, like 5 volts power one. If you take these, just I show you the alveoli. You can see all these missions, all these boards, right? Usually you will connect into the X86 platform. When you open the X86 server, inside the X86 server, you will connect these are these things. These are the boards like what you can do is in the acceleration side, from the x86 side also you will execute, like from application you will run on, from the application will be run in the from your host. Okay, application will run on the host and the kernel will be run on the acceleration board. So when you run the application, so these are all PCIe card based one, as I just explained you, like from the application, the application whichever we have seen the main program, from the main program the data will be copied to the this hardware board acceleration platform. The acceleration platform will perform the computation and again give that back the results to the application. So this board uh, this is connected on your x86 in the x86 PCIe slot will connect these things. Okay, so this is a one of the acceleration platform which people are using for IoTs. IoTs means not like a, which there is a power not power centric kind of thing. This will consume the yeah. I'm repeating the point, like mostly nowadays the CPU offloading is happening. It is not only computational part, the networking side also. You might have heard about the TCP segmentation offloading. So in that process also, what we'll do is the receiving packets and all, it's not perform the CPU, the offload, the computation part and all will be handled. That is called a TF4 TCP. Yeah. One of the part is a TCP offloading. One example is, and another one is the RDMA, remote access DMA. Usually we know like DMA is a capable of uh, doing the IO operations, right? Without involving the CPU. So what is a remote DMA means? The remote DMA has capability. It will copy the data from your hardware buffers to directly to the applications. So that is a one concept called RDMA, remote DMA capability. So few of the protocol like storage center protocol like NVMe over Fabric protocol storage solutions, they are using this RDMA concept. RDMA concept is a remote DMA. So that is we also called as a zero copy operations. So basically everyone is trying to do the maximum part they're offloading to the CPU. The same thing came up with the GPU also, graphical process unit. So this is a just general update on the storage solutions, storage and networking. If you have any questions on the storage and networking side, any like latest trends and all, if you want to know, if you want some information, you can approach me. You can check with Kamraju sir. So you can approach me anyway. So come to the my PhD part-time side. I started just recently. I completed academic work in IIIT part-time one. So I'm planning to do work PhD on the real-time systems, the real-time system side data freshness concept. Of course, this also come like a, before initially I started with the data freshness, right? The data freshness in the real-time system. So the scheduling algorithms in that area I'm planning. Sorry, my network, I unexpected thing like morning it worked well. Somehow from afternoon it is getting frequent disconnect. And I'm planning to show the demo on the hardware board, my Raspberry Pi board, whatever I have developed that. Somehow it gave me the serial port issue. So it's any questions?
రామకృష్ణ గారు
సార్.
అయిపోయిందండి.
ఎస్ సార్.
ఎనీ క్వశ్చన్స్ ఉంటే చూద్దామండి, లేదంటే
యా.
I request participants to ask any questions, please.
Participants can either post the question in the chat box or you can raise your hand.
Request all the participants, please make your video on. Few seconds or few minutes. I request all the participants, please make your video is on condition. Video on.
నిన్న మీరు లేరు కదా, నిన్న కూడా చెప్పారు. Thank you very much, sir. Definitely.
Thank you, Ramakrishna Garu. Thank you very much for because of your busy with so many works. But Ramakrishna Garu is very experienced industrial person. Okay. On behalf of organizers and on behalf of resource person also, we must say sorry to all the participants because of little bit technical issues at the end. Actually, he wants to demonstrate physically by showing a hardware, but it is some problem in the hardware. Then he's searching for debugging and everything. If you have really, we'll please, if anything you want, then we will communicate to the resource person. Okay. So tomorrow we may have at 10 o'clock. Mostly only one resource person, 10 a.m. to almost 3:30 p.m. So this is a programming session, mostly Python programming for IoT. Okay. Thank you, Ramakrishna Garu. Thank you very much. Rajshekhar Garu, proceed.
Yes, sir. Ramakrishna sir, thank you so much, sir, for your valuable time sparing with us and sharing your knowledge with all our participants. Thank you so much, Ramakrishna sir.
Thanks, sir. Apologize for the technical issues.
No problem.
Yeah.
No
It's
problem.
okay, sir.
It's okay, sir.
Thank you, sir. Thank you so much, sir.
Thank you, sir. Thank you. Bye.
And I request all the participants to give the attendance through the link which is been given. And tomorrow morning at 10 o'clock, we will be starting our next means tomorrow's session. So as sir said, so that whole day, Madhu sir will be taking the session on a programming. Okay. So thank you. Thank you for your participation. Sir, close chat now, sir.
Okay, sir.
Thank you, sir. Thank you.
Okay.